Welcome to the DIY Honda Barrage channel. The Diagnostic Trouble Code, DTC P1187, indicates a low voltage condition in the FTT sensor circuit. This fault typically arises in Honda Civics between the model years 2011 to 2015. The FTT sensor, known as the fuel temperature and pressure FTT sensor, plays a vital role in monitoring the temperature of the fuel within the fuel system. It is essential for optimizing engine performance and efficiency. A malfunction in this sensor can lead to improper fuel management strategies, potentially resulting in engine performance issues or even misfires. This presentation will guide you through a detailed troubleshooting process to identify and resolve the underlying issues associated with this DTC, ensuring that your Honda Civic runs smoothly and efficiently. The DTC P1187 specifically pertains to the fuel temperature and pressure FTT sensor, which is integral to the vehicle's fuel system. This sensor is typically located near the fuel injectors in the engine compartment. Its main role is to monitor the temperature of the fuel, providing crucial data to the engine control module, ECM, for optimal fuel delivery and combustion processes. If the voltage reading from the FTT sensor is lower than expected, it indicates that the sensor may be malfunctioning or that there are wiring issues. This issue can disrupt the fuel management system, leading to increased emissions or poor engine performance. The HDS, or Honda Diagnostic System, is used to check the data list and monitor the sensor readings effectively. Several factors could contribute to the appearance of DTC P1187. Firstly, wiring issues between the FTT sensor and the PCM are potential culprits, as damaged wires can lead to incorrect voltage readings. Secondly, the FTT sensor itself may be faulty, which means it has failed to provide accurate readings. Additionally, poor connections at the PCM or the FTT sensor could also lead to communication failures. Lastly, if the PCM software is not updated or is incompatible, it could misinterpret the data from the sensor. Ensuring that each of these components is functioning properly is critical for resolving the DTC and restoring vehicle performance. The symptoms associated with DTC P1187 can significantly impact vehicle operation. One common symptom is engine performance issues, which can manifest as a lack of power or hesitation during acceleration. Drivers may also notice an increase in fuel consumption, as incorrect fuel temperature readings can lead the ECM to inject more fuel than necessary. Another key indicator is the illumination of the check engine light on the dashboard, alerting the driver to a potential problem. Lastly, an unstable idle can occur, where the engine may oscillate in RPMs while at a standstill, indicating that the FTT sensor might not be properly relaying information about fuel temperature to the PCM. For the first troubleshooting step, begin by turning the ignition switch to the on position, specifically to the second position marked II. This action powers the vehicle's electrical system without starting the engine. Utilizing the Honda Diagnostic System, or HDS, check the data readings from the FTT sensor. If the reading indicates a temperature of 356 degrees Fahrenheit, approximately 180 degrees Celsius or more, or a voltage of 0.08 volt or less, this confirms that the failure is present, and you would proceed to step 2 of the troubleshooting guide. Conversely, if the readings are within the expected range, this indicates an intermittent failure, suggesting that the system may be functioning correctly at that moment. It is essential at this stage to check for poor connections or loose terminals at both the FTT sensor and the PCM. In the second troubleshooting step, start by turning the ignition switch to the lock position, entirely shutting off the electrical systems. Once turned off, disconnect the FTT sensor 2P connector. This is essential to isolate the sensor for individual testing. After disconnection, turn the ignition switch back to the on position again. Use the HDS to check the FTT sensor readings one last time. If the HDS indicates a temperature readout of 356 degrees Fahrenheit or more, or a voltage of 0.08 volts or less, proceed to step 3, as this further confirms that the FTT sensor is likely at fault. If not, it may be necessary to replace the FTT sensor itself and perform repair verification afterward to ensure the issue has been properly resolved. Step 3 involves verifying the wiring associated with the FTT sensor. As before, turn the ignition switch to the lock position. After this is done, utilize the HDS to jump the SCS, Service Check Socket line. This essentially helps in diagnostic procedures. Next, disconnect the PCM connector A, which has 49 pins, to enable direct access to its wiring. Now, it's crucial to check for continuity between test points 1 and 2. Test point 1 is located at the FTT sensor 2P connector number 1, while test point 2 refers to the body ground. Establishing continuity indicates whether there is a short in the wiring between the FTT sensor and the PCM. Confirm that the connections are secure and intact. The final repair verification step ensures that all troubleshooting has been executed thoroughly and that the issue is resolved. Start by turning the ignition switch to lock and then meticulously reconnect all previously disconnected connectors to restore full circuit integrity. After reconnecting everything, turn the ignition switch back to the on position to power the system. Now reset the PCM using the HDS. Resetting the powertrain control module ensures that it clears any historical error codes and relearns vehicle parameters. Lastly, check for any pending or confirmed DTCs using the HDS. If DTC P1187 appears again, investigate poor connections or loose terminals. If there are no additional codes, the troubleshooting can be considered complete. Preventive maintenance is key in avoiding future occurrence of DTC P1187. Regularly checking the FTT sensor connections and ensuring they are free from dirt or corrosion can help maintain proper conductivity and performance. Updating the PCM software is crucial, as these updates often include fixes for known issues or improved performance strategies. Inspecting the wiring for any signs of wear, fraying, or damage will also prevent electrical issues before they manifest as DTCs. Scheduling periodic diagnostics can be beneficial to preemptively catch errors before they escalate into more significant problems, ensuring the longevity and reliability of your Honda Civic. In conclusion, DTC P1187 indicates a low voltage condition in the FTT sensor circuit, which can lead to various engine performance issues. Understanding the roles of the FTT sensor and the PCM is critical for effective troubleshooting. We covered specific step-by-step procedures, including verifying the problem, checking the FTT sensor and wiring integrity, and concluding with repair verifications. Regular maintenance and proactive checks on the electrical components can mitigate the likelihood of this DTC appearing in the future. Following this guide will ensure your Honda Civic operates smoothly and efficiently, as addressing these issues promptly preserves its overall performance and longevity. Please like and subscribe to the channel. See you next time.